So I thought it might be a good idea to give you guys a separate video here on graphing of these exponential functions too, okay? Because I know that they can be a little bit confusing, so hopefully I'll try and make a little bit of a connection here for you. We're going to start off with this basic function f of x is equal to abx. Now we know that the a at the front here, right, often changes the shape of our graph, and the base will change a little bit too here, and so we're going to look at all the different permutations. Well, not all of the different ones, but a bunch of different ones. Okay, so the first thing I actually want to look at is let's pick a base, a simple base of 2 to the power of x. Now, if you were going to make a table of values here, right, an x and a y, and if you chose a table of values, say for example, I like to always choose them sort of left and right of the y-axis, right, a little bit left and right. So let's start with 3 and then go to 1, 0, -1, -2, -3. Let's see if we can make some sense. So 2 to the power 3 would be 8, 2 to the power 2 is 4, 2 to the power 1 is 2, 2 to the power 0 is 1. Careful with that. 2 to the power -1 is 1/2, 2 to the power -2 is 1/4, and then 1/8, okay? If you want to see why that is, well, look, 2 to the power of -1 is 1 over 2 to the power of 1, right? Remember negative exponents. If I have 2 to the power of -2, that's 1 over 2 to the power of +2. So you got to remember your negative exponents. Now, if we were going to graph this, right, on an x-axis, if I go to 3, I'm up at 2, 4, 6, 8. If I'm over at 2, I'm up at 4. If I'm at 1, I'm at 2, 0, 1/2, 1/4, 8. So what you're hopefully going to see is that you have a graph that goes like this, okay? And it has a horizontal asymptote, right, at x at y equals 0. So this has a horizontal asymptote at y equals 0. Now we'll be able to move that horizontal asymptote up and down as soon as we start doing transformation, right? So for example, if I had y equals 2 to the power of x, if I wanted to make the whole thing go up 1, I would just go +1. And then your horizontal asymptote would be at y equals 1. Okay, so it's this whole graph just shifted up 1. We've got to maintain those consistencies within the transformations. There's no difference, okay? I'll dig into that a little bit more in a sec. Or, yeah, well, maybe I can even do that now, right? If you had, for example, now this, 2 to the power of x minus 3 minus 1, well, you can see hopefully right away that your horizontal asymptote is at y equals -1. But what's happened here? Right? This means that the whole thing's shifted right 3. So you take every point and move it right 3. So it'd just be this graph gone down 1 and shifted to the right 3. Okay, so don't forget that the transformations are exactly the same. What you need to understand, like before, is what the basic function looks like. And this right here is y equals 2 to the power of x. Okay, now let's look at something else. Let's look at y equals 5 to the power of x. Well, if we made a table of values now, right? If we made a table of values now, let's try the same thing. 3, 2, 1, 0, -1, -2, -3. So 5 to the power of 3 is 125. That's a big number. 5 squared is 25. And then it's, I didn't spread this out enough. Here, let's just do it again. Sorry. X, y. So if x is 3, that's 125. If x was 2, that's 25. If x is 1, that's 5. If x is 0, notice that that's 1 again, right? 0 and 1. Because anything to the power of 0 is 1. And you know if it's -1, it's 1/5. And if it's -2, it's 1/25. So if you plotted these up on the same graph here, okay? If I plotted these up on the same graph, hold on a sec, let's use a pen now, just to show you. So I can't plot that, but if x was 1, I could see that it'd be up at 5 here. And if x is 0, you can see I'm at 1 there, and then it's 1/5 and 1/25. So what's happened here is that you've just got a much steeper parabola, but you still have a horizontal asymptote at 0. This is y is equal to 5 to the power of x. So what happens when you increase your base is that your line gets steeper, okay? You might ask, well, what happens if you have a number smaller than 2? Well, that's what we're going to look at right now. Think about this. If it got down to, say, 1, what would be y is equal to 1 to the power of x? So you can see that as the base increases, it gets steeper, steeper, steeper. As your base gets smaller, say it approaches 1, well, what happens as 1 to the power of x? That would just be 1, right? What you'd have is a horizontal line that goes like this. And if you don't believe me, try y equals 1.5 to the power of x, or 1.6 to the power of x, and see what happens, right? The question that I want to ask you is what happens when you have a fraction? Okay, what happens if you have 1/2 to the power of x? Well, let's think about transformations. How are 2 and 1/2 compared? Or how are they the same, right? If you talk about negative exponents, it's like 2 to the negative 1 is equal to 1/2. Well, that means that you just made the x negative. And what happens when you make the x negative? It's a reflection about what? Well, it's a reflection about the y-axis. So what we need to do is make a table of values for, let's make a table of values for y is equal to 1/2 to the power of x. And here we go, we're just going to make a table of values, boom, boom. So if x, let's do it again, 3, 2, 1, 0, -1, -2, -3. So 1/2 cubed is 1/8. 1/2 squared is 1/4. 1/2 to the 1 is 1/2. 1/2 to the 0 is 1. Now -1 means you flip it, so it's going to be 2, and then 4, and then 8. So I think you can see that what we're going to have here is a reflection. So when x is 3, it's an 8. When x is 2, it's a 1/4. 1, it's a 1/2. 0 is 1. Again, always goes through this point, right? Because anything to the power of 0 is 1. So now, when x is -1, it's 2. When it's -2, it's 4. When it's -3, it's 8. And you'll see that you have a graph that is reflected around that y-axis, okay? This is y equals 1/2 to the power of x. And that covers the basic graphs, okay? Do not forget that your transformations still work in exactly the same way, okay? So if I was going to give you now an equation that looked like this, y is equal to 2 to the power of x plus 3 minus 1, okay? Like we said before, left 3 and down 1. If I had y is equal to -2 to the power of x plus 3 minus 1. Well, the negative on the outside means it reflects over the x-axis, right? How about if I had 2 to the power of 3 minus x minus 1? Well, you'd rewrite this as -x plus 3. Sorry, 2 to the power of -x plus 3 minus 1, which would be 2 to the power of, then we factor out the negative like we always did, right? And now you can see that it's gone right 3. It's gone down 1. And the negative outside means reflect over y. And you've got it, okay? We will obviously practice these more once we start dealing with logarithms, but I just wanted to show you quickly what the exponential functions look like.